Okay, so in today's video, we're going to be going over stock beta. So stock beta is a common analysis tool used in screening or just quick analysis of a stock. So beta is a risk measure, and it measures the volatility of a stock as compared to the market. So it ranges 1 equals the market volatility, and then greater than 1 is more volatile than the market, and less than 1 is less volatile than the market. And so we're able to calculate that, and it kind of gives us more customization and ways to visualize it, so we can see the regression and see if there's any outliers or high leverage points that can throw off our number or be causing us to see a number that may not be a good indication of the stock's risk. We could also change the time periods. So say our investment horizon was 10 years or 20 years, then the typical beta of 5 years and a month would be an okay estimator, but we can really tailor the calculation to what suits our needs. If we were doing a shorter investment horizon, we may do a year with weekly data or daily data, all really depending on your risk tolerances and your investment horizon. Another thing is we can kind of do some metrics to see if there's like some heteroscedasticity or autocorrelation in our calculation to see if beta is really a good indicator of the market influencing the returns of the stock. And so I'll be doing that in later videos. This one's just calculating beta and going over it. So to start, we just import our imports. If you don't have any of these packages installed, I would install them. The warnings here is just to get rid of some yfinance warnings. Some packages that just need to be updated. And so to do this, I created 2 functions. The first, get daily data. So it takes a ticker, the period, the interval, and then close only. I did this so if you just wanted to copy and paste this for any other use, you could just set close only for false, and you get the open, high, low, and stock returns and stock splits information as well if you weren't calculating beta. And then we have our calculate beta, takes the index, the stock, the period, interval, and then just beta. So if you wanted just the beta without the model, you could do that. The model kind of lets us see the other parameters and make predictions off of it, but yeah. So first it gets the index data over the period, the interval, then gets the stock data, then it merges the two, and then it gets the percentage change. So these are the returns, and then it gets the returns for the market. So what this does is it takes the percentage change from the data point before, and then gives you the percentage change, because we wouldn't be able to get any information if we just used the prices themselves. And so X is the index return, because we want to see if the index influences the returns of our stock. And then we reshape it, because that's just the input that the linear regression function takes. And so then we get our coefficient and then return beta, or beta and then the model. To show it in action, I just kind of have some code right here. I'm using the Russell 3000 just because I think it's a good indication of the market more than just the top 5,000 or 500 companies that are in the S&P. This one gives 3,000, and then I'm just using Cameco Corp, which is a uranium producer that I've been looking at recently and trying to do some analysis on. So if we run these, we get, I have to import it first. If we run this, we should get around 1.2. All right. while that loads, I'm just gonna paste in some more to visualize this. So yeah, we get 1.21. So it shows that its risk is a little more volatile than the market. So if the market were to go up by 1%, just according to beta, without factoring anything else in, it could be 1.21%. Or on the other hand, if it goes down 1.2%. Realistically, this doesn't always work. This is just the general metric that we use to estimate. So if I paste in this other code, this pretty much just does the same thing. As you can see, it's the function right here. But this allows us to visualize the regression. And so as you can see here, that's the Russell 3000 returns and then the Cameco Corp returns. And as you can see, it's pretty spread. So it might not be the greatest indicator. But if we were to pull up a company like Apple, it should be more correlated. Yeah, so you can see the data points are packed in here a little better. It's more indicative of the relationship. I think that might be the most accurate. Let's see. Yeah, I think this one has maybe a little heteroscedasticity, but it's hard to tell. In the next video, I'll be going over some functions to analyze how good of an indicator this is. But yeah, that is going over beta. One thing. I'll just show you some different time periods. So if we were to do a year and do daily data, I wouldn't recommend this, but so what? Oh. So as you can see, with the daily data, the market's a pretty good indicator of Apple. Because Apple is a large part of the market. We can do the S&P 500, and you can see that it's even closer. Actually, is it? I don't think it was. No. So the Russell 3000 is a better indicator of Apple than the S&P 500. That's interesting. But yeah, that's beta for you. If you like this video, make sure to like and then subscribe for more content on statistics of the market. I'll be going over the capital asset pricing model. I'll be going over how to evaluate your regression to see if the market is a good indicator of each stock. I'll be going over metrics to test for heteroscedasticity as well as serial correlation. So yeah, stay tuned and hope you enjoyed. Thank you.